Have you ever wondered what really happens when you tap your phone, open a website, or save a file to the cloud? It all feels so simple, so instant, but beneath that surface is a vast, complex world that makes everything possible. Most people just use technology, but for anyone who wants to build, design, or truly understand it, we need to look deeper. Understanding how modern systems work is no longer just a nice-to-have skill, it's essential. So, let's start at the very beginning. When you run an application, it doesn't talk directly to the computer's hardware. That would be chaotic and unsafe. Instead, it communicates through an operating system, which acts as a bridge between your software and the physical components, like the CPU and memory. And in the world of modern technology, one operating system stands above the rest: Linux. You might not use Linux on your personal computer, but you interact with it every single day. The vast majority of websites, mobile apps, and cloud services are powered by Linux running silently in the background. It's the invisible engine of the internet. At its very heart is the Linux kernel. Think of the kernel as the ultimate boss of the computer. It controls everything. It decides which programs get to use the CPU, how memory is managed, and how data is read and written. Nothing happens without the kernel's permission. Everything you use, like your web browser or command line tool, runs in what's called user space. These applications are separate from the kernel. When an app needs to do something important, like read a file or send data over the network, it can't do it directly. It has to ask the kernel for help by making a system call. The kernel then checks if the request is safe, performs the task, and sends the result back. This strict separation between user space and the kernel is a core reason why Linux is so incredibly stable and secure. If one application crashes, the rest of the system keeps running smoothly. This design is what makes Linux perfect for servers. A server is just a powerful computer that's always on, waiting to provide services to other computers. When you visit a website, your browser sends a request to a server, which is almost certainly running Linux. That server's kernel is busy managing thousands of simultaneous connections, database queries, and other background tasks all at once. It's the traffic controller for the internet, ensuring every piece of data gets where it needs to go quickly and securely. Now, let's talk about the cloud. The cloud isn't some magical, abstract thing floating in the sky. It's actually just massive data centers filled with thousands and thousands of physical servers, all running Linux. Cloud providers like Oz, Google Cloud, and Azure have simply built another layer of technology on top of this Linux foundation. They use technologies like virtualization and containers, which allow them to run many isolated virtual systems on a single physical machine. This is where things get really interesting. Tools like Docker and Kubernetes, which are essential for modern software development, are built directly on top of core Linux features. These features allow applications to be bundled up into self-contained units that can be deployed anywhere, from a developer's laptop to a massive cloud environment, with incredible efficiency and scalability. So, when you deploy an application to the cloud, you're really just deploying it to a highly optimized Linux environment. This is why understanding Linux gives developers a massive advantage. When you know how process, memory, and networking truly work, you're not just guessing anymore. You can design systems that are fast, reliable, and secure because you understand the foundation they're built on. You stop just writing code and start engineering real solutions. Linux is also incredibly customizable. You can tailor your environment and automate workflows to fit your exact needs, which is a critical skill for any serious engineer. Looking at the big picture, it all connects. We have the hardware at the very bottom. On top of that, the Linux kernel manages all the resources. Above the kernel, applications in user space make system calls to get work done. These applications run on servers, which handle requests from all over the world. And finally, cloud platforms use Linux to scale these services globally. This layered architecture is the blueprint for the entire digital world. So this brings our journey to a close. From the kernel to servers and all the way to the cloud, Linux is the bedrock that makes it all possible. If you want to grow as a developer, a DevOps engineer, a cybersecurity expert, or a systems architect, learning Linux is one of the best investments you can make. It unlocks a deeper understanding of how technology really works. If you found this video helpful, please give it a like and share your thoughts in the comments below. Don't forget to subscribe to the channel for more deep dives into the systems and logic that power our world. Thanks for watching, and I'll see you in the next one.